and other sponsors, including the Basic Education Department. As you can see, today we are going to be dealing with coding and robotics, which is a very vital aspect of our subject integration. We would want you to start looking at the world in a way of being practical in your subjects. That's why we are going to be talking more about coding and robotics. So for those schools that are already using our smart labs, you will be able to even do so much more with this particular course. Just as we did with the other subjects, you see that our lessons are interactive from SMART. So you can log into hellosmart.com for any assessment. And you can sign in as a guest. You sign up there. And you also have an ID. In this case, it's 598751. So that is the ID you can use for you to be able to do some of our assessments. Okay, so it will be a very interesting journey as we start our robotics and coding. We are dealing with coding and robotics, which is from same labs. So I'll be talking more about this particular kit, which comes in various formats. My name is Rollins, and I am going to be taking you through the journey of coding and robotics. Let's take our first step. As you can see, it will be very explosive and interesting as we go on, and that's how interactive it will be. Here's a picture of some of the things that we'll be doing. These are learners who are interacting with the material of coding and robotics. So they are using the kit that I've just shown you briefly, and they are interacting with it. We will be showing you that there is a direct link between everything that you face or touch in the world with what is actually in coding and robotics. So coding and robotics is not something that is out there, but it is what you have been doing even from day one. But we are simply putting it in a systematic way. So even if you are switching on a light or switching it off, it is a coding involved, because there's an event that you are actually doing, and then there's an action that happens afterwards. You are actually actioning this particular program. With coding and robotics, you see that there will be quite a lot of things to learn. Very interesting things. This will be a very hands-on course. There will be a lot of systems that you learn. It's very interactive, intuitive. There's a lot of drag and drop coding. So you won't be necessarily dealing with those abstract coding languages at this point. You will simply see that it's very easy to program. Anyone can program. It's not for science or maths people or technology people. Anyone can actually program. Whether you are doing geography or accounting or English, or anything comes in robotics. You also see how you can understand self-driving cars, project-based learning, Internet of Things, wireless, and all these easy-to-build programs. As you go further, you see that you start to look at some more abstraction now, some algorithms, some computational thinking comes in more, and some game-like learning, some animations, and you deal with what we call things like Boolean and all that. Those might be terms that are still a bit strange to you, but we'll understand them in a very easy and everyday approach with SEMlabs. The keywords in this particular lesson that you can look out to also be dealing with is algorithm. We'll also talk about input, output, event, and action. So you can actually try to define some of these words. Let's begin by talking briefly about what is an algorithm. You see, it's a big word, but actually an algorithm, as I said, it's what you are doing every day. When you wake up, for you to go to school, for example, you actually use an algorithm there. Maybe you say the first step, I wake up, I brush my teeth, and I bath, I change my clothes, I take my breakfast, all that. It's an algorithm towards arriving at school. So an algorithm is a set of steps or instructions that are aimed at producing a product. So if I want to make coffee, you already know the kind of algorithm I need. There are some inputs. When I'm making coffee, I need some coffee, I need some sugar, I need some hot water. Those are inputs. Then those inputs will go into sort of a function. So the function is you mixing them and making a product of coffee. All those steps that you are following are an algorithm. So the output will be a hot cup of coffee, and that will be a program that was successful. So here is already something to discuss. In computing terms, what is a set of instruction called? So in this one, I'm not going to put it out there for you to answer, but I want you to start thinking about this. So a set of instruction, is it an event, an action? Is it an algorithm? Is it a list? So all these are computer terms, but which one is correct? So you already mentioned just now that a set of instruction is B, an algorithm. In your workbook or with a partner or with anyone who is close to you, you can actually talk about the event and action for automatic lighting at, maybe let's talk of a town that we want the lights to go on every time at night, but we want it to happen automatically without us switching on all the streets. So you can imagine that if it's a big town, you need to switch on all the different parts of the street lighting. So you want it to be automatic without even switching on any button. So how will that work? So just have that in mind as we look at other situations and various capabilities of coding and robotics. Okay. On this part, just re-emphasizing that when you are dealing with a program, you have steps that you follow, which is giving you an algorithm, and then there is a sequence within those steps. Okay. So in our program, as you shall see, we will be having some steps that we'll be following. Okay, so what is SEMlabs? SEMlabs is a very interactive coding kit that comes complete for different programs and objectives that we can cover. There are different types of kits, as you can see, and They come with very interactive gadgets. The kit that we are going to be talking about for this time will be the STEAM kit. So STEAM, which is STEAM, simply means we are dealing with these objects mostly talking in terms of your science and technology, your engineering, your arts and maths. So this is the kit that we'll be dealing with. Very simple and yet very interactive and creative things that you can do with it. So this kit comes with different parts which we will be putting together in achieving our goal, which is to create the world. So we are actually creating the world in coding and robotics because we want the world to be a better place to live. So we want to create things that will help the humankind in various ways. This kit, as I have just mentioned, we have different parts. For example, some of the parts here would include, there's some wheels. There are 2 wheels on this one. Then attached to the wheels, I've attached the motors. So we have the DC motors just underneath. And then you'll see that if we turn it the other side, I have attached actually another wheel, which is in a ball bearing. So this is something that can move around. It's the 3rd wheel on this particular arrangement. You could call it a caster wheel. And then you also have your light sensor, which is very handy. And the material used here is something that you can easily grab. Even for younger kids, they won't have problem of dropping too much of the components and looking for them and waste time. While it's a very strong type of material used here, and it's tactile, you can hold it, it's easy to manipulate and move it around. And this is another sensor, which is actually a RGB LED. So we have different components that are involved, and parts of the body structure can also come from this. We also have wheels in the form of gears. So this will be a gear, just as you have gears on a car. This will actually give you more mechanical advantage if you attach them to the wheels. So this is the different aspects of this particular kit. And these are some of the parts I've been showing you. You can also attach other everyday objects, like here you could put an ice cream cup, and you want to carry that a certain distance or to deliver something. It will be important to download SEMlabs into your device, or rather gadget that you are going to be using. If you have a smartphone or a laptop, you can actually download SEMlabs for free into your device. And I've shown it here on the Play Store or your Google Store or whatever store you use for your particular device. You will see that you will be able to download it in a very simple way. And it will come, these are some screenshots of how it will look on your screen. So go ahead and simply go to your Google Play Store and then go to SEMlabs. If you are using any other application, just go to your store and search in the App Store SEMlabs. Then you get this particular icon, and you are on the road to more coding. When you do that, you will see that it comes like this. So the software will look like this in your device. We are dealing with block programming, so it's very simple programming that you are using that particular program to actually program all this. So as you can see on the board, we are simulating, or we are actually showing that you are using a light sensor to program it with different other things that we'll talk about, but it's there just as a picture. So you simply move it around and connect it with wires. So it's a very simple program to use and very interactive. So if you don't have your device, you didn't have the kit itself, you can also go to VirtualBlocks. So VirtualBlocks will allow you to do coding without necessarily having the kit itself. So you can do all the programming you want with VirtualBlocks. So it will be a very good simulation where you don't necessarily have the physical kit with you. And if you have done programs like Scratch and all that, you see that those are also block programming. And with VirtualBlocks in SmartLabs, it's very simple. So there is your screen showing you some of the programs that I've put there. So you can actually connect different things. Very simple way. As long as you click on inputs, you get all these different inputs devices. So right at the bottom of your app, you see that there'll be the inputs. So these inputs actually include your key press, your button, your light sensor, like the one we have shown, the slider, the tilt, the pressure sensor, the proximity sensor, the heat sensor, and the dimmer. So all these are inputs because they are used to give an input to the program. When you press a key, maybe something happens. When you press a button, maybe when you have a light coming in, and when you have sliding certain values, or you tilt your phone or any gadget, you are putting some input there, a stimulus. You also can put pressure or be closer or far from a place, that's proximity. You are putting heat and you have a dimmer, all that is inputs. So I hope that you have an idea of what are inputs. If you haven't downloaded this particular software, this course is an introduction to show you what it's all about. And it will be such a great step from here because you'll be knowing what is in front of you in terms of where you want to go. So this is going to be a good eye-opener program for you to be able to use SmartLabs. If you were to press outputs on the very same app, you see that it will show you the output devices, which can be a camera, it can be a sound player, it can be a log findings, it can be RGB, LED, like the one that I was showing here. That's that. It can be a DC motor. Remember our motors that are on the robot. It can be a buzzer, as well as a vibration motor or a servo motor. So all these are outputs. So by output, we mean that they get to be stimulated to give an action. So all these, they get some input and then they react. So if it's a sound player, it's getting a sound file or something that is a sound coming in, and then it gives the output of sound. If it's a DC motor, it's being given instructions electronically to say that maybe move forward or turn to the right and so forth. So all these list here is showing the outputs. Next are the behaviors. The behaviors are sort of like the stimulus or things that you are going to input within that program so that you start to control the behavior of the output. So those can include some numbers that you want to be part of the program, some switch, some time, some logic, some colors, some sound, some motion, some data. So looking at this, if you have a program such as this is a complete program, the one on top. Then this one is another program, complete as well. How did I make these programs? If you look here, simply by putting this, by dragging it from your inputs, then putting this one, putting that, then it shows you the result, that there will be a light that will light on that part. So all these are programs, and you are simply putting your, in this case, because I usually read from left to right, like most of you, I put my input on the left and then my output on the right. So left input, right output. And in between, you might put these behaviors that you want to affect your input to arrive here in a certain format. So you might want it to arrive in a certain time, or maybe you want it to give some bit of colors inside, or you want to change the sound somewhere and all that. So that's how simple this programming is. Your inputs, and then in between you can put some behaviors, and then outputs. I'm going to look at some of the aspects that we have just mentioned, which I want to just give you a quick rundown to say, for example, what is a button? So a button is a symbol switch that when you press it, it might allow you to do a certain action. So like if you press on a button, maybe to switch on a light. How do you use a button in real life? You use buttons in certain places, like you want to cross certain robots, you have to press a button for the red light to come on the traffic so that you can cross. You might use it for elevator buttons and so forth. There are buttons everywhere in life. You can also have another part of this, which is our buzzer. Our buzzer is simply one that will convert a signal into a vibration. So when a signal comes in to a buzzer, it will vibrate. Okay? So if, for example, I connect a button to a buzzer, then when I press the button, the buzzer will go like that. And buzzers are used maybe in some timers, and they will give you that typical sound that your phone gives you when it's on vibration as well, the sound of it. And then coming in different frequencies, of course. You can use it also on certain games and other quiz shows where they use a buzzer, like America Got Talent and so forth. So that buzzer will be made in this format. Another component is the DC motor. The DC motor, as I've shown you on the kit, is simply like this, and it actually spins at a specific speed or direction according to whatever information you have given it. So if I use a light sensor to connect it to a DC motor, you realize that maybe when a certain value of light, you see that light has different values. So maybe at a higher value of light, which means it's bright, the motor will move faster. Then I can program it so that if the light is dimmer, it's low value, then the motor might move slow. So you could use it in various ways. Motors are actually in many different components. For example, your power tools, your elevators, your own car, as well as even remote controlled cars. So you could actually design a futuristic car as a challenge. You can also use a heat sensor to connect it, and heat sensors are used for your heater in winter, and to actually use a heat sensor maybe on your phone so that if there's so much heat, maybe it switches off and so forth. We also have heat sensors in your smart fridge. If you have a fridge that is smart, it will switch on and off, knowing that the levels of temperature are actually a certain level. Light sensor is also another component that you can use in these smart labs. So the light sensor simply detects the brightness of the environment, and it can give you a value between 0 and 100, which 0 will be so dark and 100 will be quite bright. So if you were to connect it to, for example, the RGB LED, you will see that maybe a certain light level will give you a certain color and so forth. We'll do most of these things. You can use a light sensor on your phone. Maybe when you put your phone on your ear, the screen switches off so that it's not bright on your face, to save the battery as well. That might be a light sensor. You use it maybe to make the street lights that we were talking about, so that when it's dark, the lights come on their own. You can also use it on solar panels. So you could actually invent a smart home lighting system, which I gave you that challenge at the beginning. You can also have components such as pressure sensors that are used on touch screens, bathroom scale, and even on piano pedals. And it actually senses the pressure or the amount of force per area that you'll be applying. The proximity sensor is actually a sensor that measures how close or far are you from a certain device. So for example, if you have a proximity sensor, it can actually know how far am I from the next object. So it can be used when you are doing payments by just tapping your card. You can actually know how much money is in your card and how much should be deducted for that transaction. So it's using a proximity sensor. There are certain places where you go, you want to dry your hands in the bathroom without touching anything to avoid pandemics such as COVID-19, it will actually sense your hands and dry them. You also have different applications, for example, supermarket checkout, where you don't have to be touching different parts in the supermarket, but you can use more of proximity sensors. So you can see that a lot of these components, they will help you to have a healthier world as much. The RGB LED that I mentioned already, which I'm holding here, it is a sensor that is actually going to assign a certain color between the colors red, green, blue, which are our primary colors. So it can give you a color that is a mixture of that depending on the value that has been input. And you will see a lot of our practicals where we'll be using it to color in some of our activities. And you can use it in certain light bulbs that might give you a certain ambient color because of the kind of input that is coming in. Then you can also use it on police car light. You see that there's colors on the light and even on flashlight. You could actually be able to create your own disco light with some rapid change of color as a project. So we'll be doing all these things as we go. A servo motor is simply a motor that rotates as you put an input, and you can use it for your wipers on the car, robotics arm, and some train kind of projects. Then there's also one sensor which is called a tilt sensor. So the tilt sensor will check the angle that you are moving it around. So whatever object it is within, it will check the tilt angles and orientation of it. And you could use it for your step counter when you are doing exercises for your workout. It is also used in your smartphone when you are playing games. Certain games you need to tilt your screen, tilt this. Maybe you are doing your tempo run and all that. So all that is happening because of the tilt sensor. You can use it on the helicopter in order to steer it properly. You see that I have one of our props here, which is an aeroplane. So this aeroplane, for an aeroplane to fly, it has to have certain orientation, and there will be certain dynamics with the wind and all that. So there are flaps and other parts that will be moving on the body of the aeroplane in order to give the right orientation to the wind for thrust and for all those forces. So there is a lot of application of this. Another component could be the vibration motor, which simply sends what is the vibration, which can be used on your phone, or an electric toothbrush, which is washing by vibration as well, and all that. You can also have a camera, which we saw on the program, and with your camera, let's say I press a button, then a camera takes a picture and so forth. I mean, cameras are used in different gadgets, including your phone cameras, your photo booth. If you want to take a picture, maybe at the park or at an amusement park, they also use a lot of camera there, and even traffic cameras. We also have a car controller, which you can use to control another device. So we have our simulated one on the program. So with a controller, you simply control what you want to be happening with the other device. So you use it when you are dealing with game controllers, with your remote controlled cars, and even on drones. As you can see, you can have a drone that you are controlling using the car controller. So it's very handy when you are in this world of Bluetooth and remote control. Another component is the color block, which will actually enable you to change certain colors according to the relationship to the RGB that we mentioned just now. And we know in nature there are certain animals like the chameleon, it changes color. You might be wondering, how does it do that? So you understand it better when you deal with this color block. There are leaves that have different colors and panes. Another block is the compare block. So the compare block simply look at a value or any number, then it compares it or allows it to affect the output. You might use a compare block for your computer fan. Your computer has to know at which point to start running the fan or to stop. You can also use it for your printer ink to know when to refill the ink, or your plate, your hot plate stove. You want to know, as the plate is working, it has to determine at which stage to be on and off at a certain level that you have put. So here is a little something to check your understanding. So I'm going to put a few questions just to check what you understand so far from what we have been discussing. And this is one of the questions which you can actually look at if you don't have a device. And I'm going to be connecting those who have a device to actually check what answer they can give us on this one. Okay. So with that, what does the symbol mean? What does that symbol mean? So let me just connect you on this. Let's give it a minute. So as you can see, there are about 3 questions. Which block is an input? Which block is an output? So you have options to choose from. To get these questions, you might have to relate to the previous page that we talked about, your inputs, your outputs, and the behaviors. So you can actually start thinking about it while I'm still connecting you. You can start considering which one is the input here, which one is the output. So is it the RGB LED? Is it the light sensor? Which one between them is the input? Which one is the output? Okay. So as I showed you at first, you can connect by simply going to Hello Start, and hellosmart.com will give you an option to put your ID number, which is coming shortly. So I'm sure you are realizing that it's a very interesting subject, coding and robotics. You can actually create a world of your own where everything will be useful to humanity. You can make life easier for the next person and yourself and the future generations as well. Okay, so those on the devices, I'm sure you can see the questions, and you can actually respond to the questions. So what does that sign mean? And which one is an input? Which one is an output? So I'll just give you 1 minute to answer all these questions. You can choose between the options given. Thirty more seconds. All right, we have to proceed. So let's check. We'll just discuss this one. So the symbol that was showing was a greater than sign. So if you realize from your grade 3 and 4 maths, they were telling you that if maybe it's a crocodile, so where it's opening its mouth, that's the side where there's a bigger chunk. So this is a greater than sign. You can also use your hands, the right hand. If it looks like that sign, it's a greater than sign. Left hand, it's a less than sign. Those who were doing manually, if there was an equal sign, it can also be greater than and equal to, which B would be correct. But this symbol that is on your device is simply greater than. Let's check as well as the other question. The other question was which block acts as input? And on this question, we have shown you on the program that you actually have your input as the light sensor block. So the light sensor block is your input and your RGB LED is your output. You will be working with these things a lot and you understand this much better as you are doing it practically. So one of the other sensors you can use is called a counter. So the counter block simply counts or puts numbers that you can work with. So with that in mind, you can have different numbers that you can put. Maybe these numbers, some are even numbers, some are odd numbers, some are prime numbers. You can also work with them, and you can create something that is looking a bit complex, but very easy to do, where two numbers are coming up to give us a certain value. So as we are finishing our lesson, you start to see that different components of the programming come together to give us our desired product. We can have delay components in there. We can have components that can hold a value for a certain moment. We can have that can give us intervals, and we can have inverse that changes. If it's a 0, it's a 1. If it's a plus, it's a negative. We can have key press, where you can use your keyboard, such as a keyboard, to play music on your keyboard because of that particular block. So I have one of my musical instruments here, which is a flute. So this is simply a recorder, which you can actually play music around. So all these things, they do come together, and you can make very interesting products. And your sound, which you can connect to different array of components to give you a result. You also have a text block, which is the last block I'll talk about. So the text one will be simply you put your value in terms of characters, and you get a desired end. You will use this a lot on your phone as you are chatting and so forth. So in our programs, you will be debugging, which simply means you'll be looking for errors that you might make. You solve them, you test, you also have more understanding of what is happening. For example, on this question, which block enables you to take a picture? You can almost figure it out. Which one of these four would take a picture? So it will be the first block. And our exit ticket is that what have you learned today? And can you say that coding is creative? It's interesting. It's able to help the world in terms of pandemics such as COVID-19. We talked of the proximity block that you can actually use without touching anything. You can still achieve your functions in a more smart way. So we have actually started on our smart labs. I believe that you'll be able to download the software freely from your app store, and you start to practice and just find your way around this program. You will see that it's very intuitive. It's easy to learn because it's block programming. So you won't have to know about C++ and all that. For now, you simply get in and you fly with it. So thank you very much as we finish our session.